Hi class, me Mr. Morris, and we are going to be talking about covalent naming and formula writing today. You learned the difference between ionic, metallic, and covalent bonds last class. Today we're focusing on covalent bonds and how that we name and write formulas for those types of compounds. First of all, let's review what they are. A covalent bond is formed between two nonmetals when they share a pair of electrons. So you start out with atoms that have unpaired electrons, and they get close enough to each other that they can combine those electrons and share electrons so that they both have 8 valence electrons. Recall that electronegativity is the ability of an atom in a bond to attract shared electrons to itself. So if you look at this diagram, atom B has a higher electronegativity because it has a stronger ability to pull the electrons towards itself. But atom A has lower electronegativity. It doesn't have as strong of an ability to pull electrons towards itself. And if you click on this link here, it'll take you back to the answer key for our periodic table and periodic trends notes. You can click on the P table trends, that's the second tab, and remind yourself of what the trends are. So electronegativity, the most electronegative elements are over here to the right of the staircase, and those are our nonmetals. So what type of elements have the highest electronegativity or most strongly attract electrons to themselves? That would be nonmetals. Thus, the molecular or covalent bonds, molecular or covalent compounds, are formed between a nonmetal and another nonmetal. And the way that they form these is by sharing electrons. So let's look at how we're going to write names for this. So if you're given the formula and you're trying to find the name, we're going to use prefixes when we name covalent compounds. The prefix is the number of atoms in the given element. The number of atoms of a given element in the compound. Those are shown as a subscript. We're going to look through some examples, but an example would be something like H2O. Well, let's use one that's a little less common. So maybe CO2, that's carbon dioxide. That O2 tells us there are 2 oxygen atoms. So CO2 would be carbon, 1 carbon, and then dioxide, there's 2 oxygens. We'll go through several examples to go through these rules, okay? But the prefixes are going to be used to tell us the number of atoms of a given element in the compound, which is shown as a subscript in the formula. These are the prefixes we're going to use. You won't go above 10 in this class. So mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. It's a good idea to put those to memory. A lot of them you're already familiar with, but the ones that probably stand out as the trickiest are maybe tetra, 4 tetra. That's one that some students don't necessarily know off the top of their head. Hepta. A lot of students are more used to hearing septa instead of hepta when we talk about 7. And maybe nona. Those are probably the ones that are the most commonly messed up. So watch out for those. Tetra is 4. That's probably the one that I see missed the most on test or quiz. There are 2 elements in every covalent compound you're going to have to name. So the way that this is going to work, your first name is just the prefix plus the first element's name. Don't change the name, just prefix and the first element's name. The second name is the prefix plus the second element's IDE name. But there's an exception. There's a special exception that only applies to the first name. We never use mono for the first name. So if there's only one of the first element, you don't use mono. But if there's only one of the second element, we will use the prefix mono. Okay. We'll do some example problems down here. So go ahead and get started with that. Use control comma for the subscripts. Now we're going to do name to formula. Let's start with that, name to formula. So diphosphorus, remember this is my prefix, di is the prefix, that means there's 2 phosphorus, so I can put P, which is the symbol for phosphorus. I'm going to do control comma to make a subscript, P2, and then it says pentoxide. Penta is the prefix, and we dropped the A, that happens sometimes. And then oxide, which element would oxide be? Well, that would be oxygen. So it's P2O, and penta means 5. All right, bromine triiodide. Now, I don't see a prefix on the first name, so that tells me that I only have one bromine, Br. And then triiodide. Iodide is iodine. And then there are 3 of them, because tri means 3. Tetra-arsenic hexoxide. And you might see this with an A or without an A. A lot of times we drop the A if it's right next to an O. Okay, tetra-arsenic hexoxide. So arsenic is As, and there are 4 of them. Tetra means 4. Tetra-arsenic, As4, hexoxide, that's going to be O6. Okay, dinitrogen monosulfide. 2 nitrogens, so N2, and then mono means 1 sulfide, which is sulfur, so just N2, and then S. Carbon tetrachloride. There's no prefix on the first name, so that's just 1 carbon. Tetrachloride, Cl. Tetra means 4. All right, pause the video, try a few examples in the practice, and then come back after about 5 minutes to learn the second half. Okay, so we did some examples of going from name to formula. Now let's go formula to name. So remember the rules that we talked about up here on the first page. The rule is it's going to be the prefix plus the first element name, then the prefix plus the second element's IDE name. The special rule is we never use mono for the first nonmetal. So let's go down here and do a few of these. So I have 2 Ns. N is nitrogen. If I have 2 of them, I've got to put a prefix di. Di, nitrogen. Don't change the ending of the first name. We're just going to change the ending of the second name. Dinitrogen, and then 4 oxygens, that's tetra. And then oxygen is oxide. Change the second name to IDE. Now, you would probably write it this way, and I would give credit. A lot of times with this type of name, the A would be dropped because it's right next to an O. I'm not going to expect you to know that off the top of your head. Just understand when you're answering multiple choice questions that sometimes it's not going to be exactly what you think it is because we drop an A or an O in the prefix. Or not in the, in the prefix for the second name. All right, we get to carbon, so C and O, CO. C is carbon. Now you might say monocarbon. But don't forget, the first name, we don't put a prefix. So it's not monocarbon, it's just carbon. Okay, that would be counted incorrect. You got to make sure that you know that. The first name never has the prefix mono. It has prefixes for 2 and above, but it does not have a prefix for 1. We only use the prefix mono on the second name. So then we get to oxygen. We've got 1 oxygen. And remember, second name is going to end in "ide." Monoxide. That looks kind of weird. That looks like monoxide. Again, I would probably count that fine if I were doing a free response question. But we drop one of those O's to call it monoxide. Carbon monoxide. By the way, that's a gas that comes out of your car. You've probably heard of carbon monoxide poisoning. That's when somebody inhales too much carbon monoxide, which comes out of the exhaust pipe of your car. Okay, SF6. SF6. First name does not have a prefix if it's only 1. So we're not going to use mono. It's not monosulfur. It's sulfur. sulfur, and then fluorine, we've got 6 fluorines, so we're going to say hexa, that's 6, fluoride. Sulfur hexafluoride. All right, the next one is Cl2O3. I've got 2 chlorines, so that's going to be dichlorine. And then 3 oxygens, that's trioxide. I have Si, and I have 4 H's, so that's not mono, it's just silicon. And you would probably want to look at your periodic table for these if you're not totally familiar with the names. You can find it. Find Si on here, which is going to be easier to find on this page. Si is on the staircase. There it is, silicon. And that's where I'm getting this information, silicon. And then 4 hydrogens. So you would say tetra. A lot of students would not know exactly what to say here. They might put hydrogide. But that's not the way we spell the IDE name for hydrogen. It's actually hydride. We drop a little bit more because that's an awfully long last name for an element. Silicon tetrahydride. All right, we've got one more section I want to go through real quick. And this is just, all of these are mistakes. Every one of these is a mistake, but I want you to catch the mistake. So please try to pause the video and figure it out for yourself, and then listen to the explanation. So this first one, 2 nitrogens, 8 sulfurs, sorry, into S8, we called that nitrogen sulfide. Why is this wrong? Well, I hope you identified it. The reason this is wrong is because no prefixes are written. The correct name would be dinitrogen monosulfide would be the correct name. All right, let's go to the next one. What's wrong with C2F6 being called dicarbon hexafluorine? Well, the second name should end in IDE. So the correct name is dicarbon hexafluoride. SO4. What's wrong with SO4 being called monosulfur tetroxide? The reason this is incorrect is we don't use mono on the first name. Okay? The correct name is sulfur tetroxide, or tetraoxide, either one would be fine. NO is nitrogen oxide. What's wrong with that? Well, we don't use mono on the first name, but we use mono for 1 on the second name. The correct name would be nitrogen monoxide. Carbide tetraiodide for CI4. So I have CI4, carbon tetraiodide. What's wrong with this? I'm sorry, it says carbide tetraiodide. The first name shouldn't end with IDE. We don't change the ending of the first name to be IDE. So, the correct name is carbon tetraiodide. SiH4 is silicon trihydroxide. What's wrong with this? There's actually two mistakes. All right, first of all, the prefix for 4 is tetra, not tri. Secondly, the IDE name for H is hydride, not hydroxide. Hydroxide is something else. Okay, if we use the word hydroxide, we're referring to OH minus. That's a polyatomic ion because it's got an X in the middle of it. There's no X in hydrogen, so that's not right. Okay, it should be hydride, not hydroxide. So what's the correct name? The correct name is silicon tetrahydride. All right, that's it for covalent naming. Try the practice problems and let me know if you have any questions.